But these particular cells, they refuse to die, they refuse to be recycled, and worse, they secrete something called SASP. They're making other humans zombie, right? So these bad cells, not dividing cells that refuse to die, they're now affecting healthy cells, make them the same.
The issue is not having senescent cells. It is the process that leads to more senescent cells and then having more senescent cells. Welcome back to Biohacking Beauty. I'm Amitai Eshel.
I'm Anastasia Khojaeva.
And today we are going to give you the part 2 of the autophagy school of self-eating. Okay, and how your skin can eat itself back into a youthful state.
Yeah.
Without further ado, let's continue. So last time we kind of broke down what autophagy is, why it's why it won a Nobel Prize, the switches, everything around that.
Yeah.
Now we're going to talk specifically about skin.
Yeah. So skin has a few characteristics that make autophagy uniquely important here versus some other body parts.
Okay. What makes it different?
First, skin has two very different cell populations living together. You have rapidly renewing cells, such as keratinocytes in the epidermis, and they turn over about every 28 days in young adults. And that's kind of like why we often hear that cell cycle is about 30 days. And a lot of the times you also, when you judge skincare products, it doesn't really make sense to judge before that, before that time period. But not a lot of people know that you also have very long-lived cells, and those are fibroblasts and melanocytes that can sit in the dermis for decades.
Yeah.
Yeah, those long-lived cells are the ones that really depend on autophagy for quality control, if you think about it.
Yeah, because they don't get replaced, right? Again, that's why I'm a little bit irked by the hyper-focus on mitophagy right now. Because when we talk about skin health, a lot of the times it's not about, destroying, for example, something like the mitochondria and then replacing it with new. It's a lot about the maintenance. And specifically when we talk about mitochondria, there are other pathways for mitochondrial health. Actually, that's only 1 out of 5 that are important because there is a capacity, as we say, to the amount of different types of autophagy you can do. So maintenance, aside from replacement, is extremely important.
Absolutely, yeah.
So basically, because they don't get replaced, just to hammer in the point, they have to keep themselves clean.
Yeah.
Right?
Yeah. If you think about it, the melanocyte, let's say on your cheek is...
we're back to the cheek.
on your forehead. The melanocyte on your nose.
Okay.
It can be older than your car. Like, it's pretty crazy to think about.
Yeah.
And then if autophagy fails, that cell is stuck carrying damaged mitochondria, oxidized protein, misfolded protein,
the machinery
broken machinery for pigment for years.
So what does it mean visually?
Yeah. So when you think about melanocytes, they're also the ones that are giving pigment to your hair. So hair grain is considered to be one of, issues with that autophagy. So melanocytes lose function, pigment production drops, again, gray hair appears. And then uneven pigmentation on your skin, like this age spots, kind of sunspots, that's all tied directly to autophagy. There was actually a beautiful paper in 2013 by Journal of Investigative Dermatology showing that keratinocyte autophagy is one of the mechanisms that dermatitis is rooted in, but also determines skin tone because keratinocytes use autophagy to degrade the melanosomes transferred to them from melanocytes.
Yeah, that kind of blew my mind. There is an ingredient we were looking at, like to replace all the vitamin C's. It's going to take a while, but they have like a literal little video, little GIF of pigment kind of traveling to the surface. They have this little thing that kind of stops the pigment from appearing in the surface, and then it gets like it gets into an autophagy cycle and kind of broken down. So this is like mind-blowing to me.
Yeah. I mean, what you're describing is kind of like a more simplified illustration of it. But in a way, what you're describing is sort of what compounds like resveratrol do and how they prevent pigment formation. And there's another ingredient I always stutter when I have to say it. It's isoliquiritigenin. Yes, and so the isoliquiritigenin, it goes by ISLT, is a key component in licorice extract, kind of known skincare ingredient. So it inhibits melanin production by controlling tyrosinase enzyme activity. And it effectively addresses hyperpigmentation caused by UV damage. And for those of the listeners who doesn't know what resveratrol is a potent antioxidant polyphenol known to reduce hyperpigmentation and dark spots by inhibiting melanin production. Again, kind of like similar to what you were describing. And resveratrol, of course, we've been using in our skincare for a while.
We use the patented form, the one that actually has a patent on hyperpigmentation reduction. Two things that are really cool with what you're saying. Number one,
with fermented resveratrol.
But the thing is this, like, I am dealing with melasma. I can tell you that it's a crazy difference if for example, if I am not a good boy and I don't use the products, and when I do, and something about resveratrol that it's interesting, it really coincides with how your body, as we say here, targets like pigmentation, very different from things, for example, like obviously like sunscreen or vitamin C, which are less congruent with how the body does it normally. This is very, very, it's a very known process as far as how the body looks at it. So that's a very good ingredient that you can confidently add to your routine if you are someone who suffers or dealing with hyperpigmentation.
Yes. So since today we're talking more about autophagy that's related to skin health, we should also talk about mitophagy in fibroblasts, I think.
Yes. Okay. So walk me through it.
Fibroblasts are collagen factories, basically. They also have the highest mitochondrial demand of any cell in the dermis because making collagen is very metabolically expensive. When fibroblasts mitochondria start leaking reactive oxygen species from UV exposure, from blood sugar spikes, from inflammation, mitophagy tags those bad mitochondria with the tags we talked about, parking and
pink one
and parking, and hopefully recycles them. That's mitophagy.
Yeah.
So when mitophagy fails, the fibroblast accumulates what is called zombie mitochondria. They can't make ATP, so they're useless, but they're still producing and leaking reactive oxygen species, and that reactive oxygen species goes on to damage the collagen those fibroblasts are trying to make.
Yeah, that's what I call splayed state mitochondria or leaky mitochondria. And we talked a lot about that. I mean, we talked around that with Dr. Scott Scher and, how and how blue peptide spray works, but more than that, like how methylene blue works, right? That's kind of one of the main functions of methylene blue.
Yeah, the psychologist.
What?
The psychologist. You said it's like methylene blue. Remember, you had the analogy that it's like a psychologist, like your usual antioxidant.
Yeah.
It has to sacrifice itself.
Yeah.
So imagine now the mitochondria is leaking like a lot of reactive oxygen species. So you have to have a lot of antioxidants, and they all like sacrifice themselves for each. Reactive oxygen species versus methylene blue, it it kind of recycles itself. So it can save you from a lot more reactive oxygen species.
It saves the mitochondria from self-sabotage, whatever it's called in, whatever. Ask Carl Jung or whoever, or Freud. Anyway, so mitophagy failure, if you would, is literally why photo-aged skin makes bad collagen.
Yeah, it's one of the big reasons. And there is a paper to back this up. So there is a 2024 paper in Biogerontology. They show that resveratrol activates AMPK in human dermal fibroblasts, and the UVA irradiated mouse skin. Basically, they saw that there is a triggering of autophagy, reduced ROS production, and visibly reversed. They were able to visibly reverse roughness, redness, and wrinkling from the UV exposure.
So the same SIRT1, the same SIRT2 gene, resveratrol autophagy kind of axis, that shows up in longevity conversation, longevity literature, more generally as well. It's a very important component, and obviously we talk a lot about it when we talk about NAD. It's a very important component as far like the operating the machinery of skin health.
Yes.
Am I correct?
Yes. And so that 2024 paper complements an older foundational paper, and that's why we were kind of talking about SIRT1 and longevity space for over like 16 years now. So yes, there was a paper published in 2010 which established that resveratrol activates autophagy through SIRT1, and that if you knock out SIRT1, resveratrol can't induce autophagy anymore. So we know that resveratrol works through SIRT1.
Okay, so third mechanism you mentioned is a mechanism that's extremely hot right now, which is senescent cells, right? You call zombie mitochondria zombie cells, kind of as a play on zombie cells, which are senescent cells, right?
Yes. And I mean, that one could be arguably the most important for visible skin aging. So senescent cells are the cells that stop dividing, and similar to how we were describing zombie mitochondria that does not produce ATP, so it doesn't serve and is useless. So are the senescent cells. They're kind of like they are no longer functioning, and usually in your body, if cell cycle is done, the cell is being recycled. But this particular, and there's like different mechanisms. Let's say there could be apoptosis where the cell actually dies. It was sent to die. But these particular cells, they refuse to die. They refuse to be recycled, and worse, they secrete something called SASP, the senescence associated secretory phenotype. So that's a cocktail of inflammatory cytokines and matrix degrading enzymes, and they just release it around them, and they basically like why they're also called zombies, like zombie, they're making other humans zombie, right? So this bad cells, not dividing cells that refuse to die, they're now affecting healthy cells and make them the same through this SASP.
Yeah, that's what I kind of alluded to in the beginning when I said, sometimes the problem, it's not that the cells stop working. The problem is actually worse than just cells stop working. So what does this, what you described right now, what does it do to the skin?
Yeah. So some will damage collagen directly, some recruit inflammation, but as I mentioned, really the worst part of it all is that it spreads senescence to neighboring cells, which is called paracrine senescence. Paracrine is when something is close. So a small number of zombie cells can poison a large area of dermis all around them and spread.
Yeah, a paracrine is the worst. No, they couldn't have just called it like adjacent senescence or neighbor senescence. No. Anyway, so how does autophagy intervene here?
It does it in two ways. First, when mTOR is suppressed, whether by rapamycin or by fasting or by caloric restriction, autophagy goes up and SASP production drops. So that's called a xenomorphic effect. You don't kill the zombie cell, but you at least stop the bad effect, you stop the damage. And then the second one will be the actual functional autophagy, which helps the immune system recognize those bad senescent cells and then effectively clear them out before they accumulate.
So yeah, that's something I think important to understand. I think people think of senescent cells just like the fact that, senescent cells drive aging. They do, but not having, so there are studies showing that not having senescent cells or not having, kind of knocking out the ability to have senescent cells doesn't actually, you might die faster. Like it's actually pro-aging. Yeah. The issue is not having senescent cells. It is the process that leads to more senescent cells, and then having more senescent cells. I had a talk. I'm just gonna name drop over here a name that no one knows about. So I had the talk. I have had a conversation with Dr. Pinchas Cohen, which is probably the most important mitochondrial researcher in the world. He owns the few patents. One is for MOTS-C, which is a very, popular peptide. Anyway, and we talked about...
That's a name drop.
Oh, yeah, name drop.
In our field, that's a name drop.
Yeah, exactly.
It's not like you were talking to Kim Kardashian or I don't know.
He's the Kim Kardashian of mitochondrial health. That's how I call him. Head of the mitochondrial field in USC. But anyway, we talked about senescent cells becoming what telomeres were like a decade ago.
Yeah.
Where everyone were like, there was a craze, also in skincare, by the way, on reducing telomere shortening. Well, telomere shortening, which are the ends of your DNA, if they shorten, your cells can't divide. It's not that if they're short, you're older. No, you're older because mechanisms are not working correctly. And now your telomeres are short, right? So that was a little bit of a tangent, but senescent cells are a big issue, not because of themselves, it's because what led you to having those senescent cells, right?
Okay.
You got, yeah?
Right. I
anyway,
got it.
So
12 more minutes to break the rest of it down.
Okay, so let's be quick about that. One thing that I do want you to point out, many early things in longevity, we have data on, skin cells or mice or rodent models, right? Is there human data to what you're saying?
Yes, there is human data. This is one I guess we should really highlight. So in 2019, Christina Chang and the team at Drexel University College of Medicine ran an explanatory randomized trial of topical rapamycin in the journal Neuroscience. So participants were over 40. They applied rapamycin cream to one hand and a placebo cream to another hand. And they did that for, I think, 6 to 8 months. Every day, almost every day. AKA
contralateral design. So every person had their own control, which is quite cool.
Every person is their own control, correct? So after 6 months, they biopsied the skin. The rapamycin had significantly fewer P16 positive senescent cells. Remember, we're using P16 as a tag protein, and then there will be a autophagosome coming, and the garbage bag will take out the improper cell. So it had higher levels of collagen at the basement membrane. It had like overall, basically there was a significant reduction in fine wrinkles, skin tone, like improvement in skin tone, and that kind of thing. So the rapamycin had like significantly looked better. So there was like biomarkers that we could attribute the effectiveness of topical rapamycin, and there was also visual effects.
Nice. So the something cool is that rapamycin is pretty aggressive. It's a really nice study to show the relationship between like senescent cells, aging, things like that. Of course, we talked about in the famous debunking of the guy talking about vampire exosomes. I talk about P16 and platelet-derived exosomes and how they lower P16 as well. And we know spermidine also lowers that, which is pretty cool.
Yeah.
So just
spermidine is the OG of like autophagy.
Yeah.
And all the different kinds of autophagy, not just like.
Yeah. So just to make sure that we're quick here, let's wrap things up and let's maybe talk a little bit about, how to incorporate spermidine in a routine. Sometimes things are, we talked a little bit in the beginning about the fact that we don't always want autophagy running high, right? And especially when we talk about rapamycin, because rapamycin, something, important with rapamycin is that it's so suppressive to growth. It's also suppressive to the immune system. It's suppressive to healing. So using it consistently on the skin when we're young, when we're healthy, when we want other things aside from longevity, optimal performance, resilience, things like that, it's a little bit of an overkill. The really cool thing about spermidine or platelet-derived exosomes is that you could have, at least your skin can have, a signal of longevity, of repair, can stop and repair, morning and evening when you apply those things. But during the day, obviously, you're eating, hopefully you're breaking your fast at some point. You're eating, you're feeding those cells with the right nutrients, and it flips back growth, right? So we can have that seesaw motion we're looking for extremely better than with something as aggressive as rapamycin, right?
Yeah. Do you want to talk about why would somebody need both spermidine in their regimen and platelet-derived exosomes, because you can't put them in the same product, for example?
No. So just exosomes are very, very tricky. They're very delicate ladies. Most 99.9999% of things you can't put them in. Okay, it needs to be in a special bottle. It needs to be with very small amount of ingredients and things like that. So you can't use spermidine peptides, NMN for that matter. The way we boost NAD there is very unique because of that. But bottom line, exosomes are perfecting cellular function, cellular activity. So they themselves are not very good at, or they're not mainly used to relay signals of renewal. They do have growth factors in them, but even those are supporting building of materials which you would stimulate renewal in other ways. So they would just make autophagy work really well. But that's something that we didn't go over. In 2024, there was a study. I think it was Frank Medeo, but I might be wrong. We'll try to have it in the show notes, where they looked at spermidine and they found out that your genes that encode spermidine, remember we talked about those 15 genes, they rely on spermidine to be encoded, meaning if you don't have enough spermidine, and I remind people that spermidine is something innate to your system, you have it, it lowers with age, very similar to the NAD story. If you don't have enough spermidine, autophagy doesn't happen. So they basically fasted. They knocked out spermidine out of, a mouse model, and they fasted these mice, and autophagy didn't happen. So spermidine is at the base of what autophagy is. We're talking about, reduction of senescent cells, things like that from exosomes. Spermidine is still an important factor for actions to even happen. So it's a very fundamental version of what that is. And spermidine induces autophagy separate from mTOR. So spermidine induces it through a different mechanism called EP300. So it's really good to cover something that you want to cover as far as cellular function goes in a few different pathways, because for the most part, what we see, by the way, for example, fasting isn't as effective at longevity, at expanding health span or lifespan, the more complex the animal is. So it's really, really good in again, C. elegans or whatever. It's not that great in humans. It's like not as revolutionary. You can't like double someone's life by fasting, right?
And also, I think it depends on what health the person is in, the
Yes,
health state.
well, that to your point, what will happen is that you have different compensatory mechanisms. So there are more pathways that will compensate for each other. I'm trying to like signal emergency for the body by not consuming like leucine specifically or something like that to induce autophagy, right? There are other mechanisms that even mitochondria, by the way, if you really stress it energetically, it can diversify and can be like, instead of like contributing energy, it can contribute different like nutrients. It's not really healthy, but it can happen. It's very new. It's like a year-old field of study. A day old. Happened yesterday. Anyway, so
you're really in the know.
I know. Ooh, they called me mitochondrion.
You're in the Pinchas Cohen.
In a Pinchas Cohen club. Anyway, you got the point, right? Like we want to cover many mechanisms to make sure there is no compensation. There is no like rewriting, et cetera, et cetera, et cetera. Like a small thing that I'll add, like, you know, if you're just as an example for a compensatory mechanism, if you want to be like in ketosis, you shouldn't have really, really high protein and no fat and no carbs. Why? Because the body's like, oh my God, I have a lot of protein and I have no carbs. What I'm going to do is I'm going to make sugars out of protein. That's why you need like high fat, moderate protein, and then like, you know, little to no carbs. It's because you really want to force the body to use the fatty acids. Anyway, so that's a compensatory mechanism that you're hitting a few pathways in order to make sure that what you want to happen. Same thing here, EP300, mTOR, AMPK, all the good stuff. But yeah, spermidine is really cool. We probably shouldn't do this podcast because that, in my opinion, spermidine is the new NAD. Like in 5 years, all the companies are going to be like, you know, releasing spermidine, and now we're telling them what to do. Well, but we're generous like that.
That makes it much more special that we're still the first and the only company to have spermidine in our skincare.
Yeah, actually not the only. There's one company called Rain that has spermidine in their product. Shout out to a budding company that has a spermidine product. The difference is that we use spermidine. So spermidine was really designed for cosmetics, and spermidine is very tricky to kind of keep stable in cosmetic formulations. So
we got really
we were very lucky.
You know, that the University of Graf worked on incorporating it in their cosmetics, and then we ended up getting all the knowledge and the ingredients.
The main researcher right now in the world is Medeo, and he is on the board. He's one of the co-founders of the company that patented Selvio, that were the exclusive. We have exclusivity for. So it's really cool to be there, to be in the bleeding edge, as I like to say.
I mean, it's always about the source. Like it's we kind of, if people listen to our previous podcasts, they know a lot of the times when you look at skincare products and the label might say the same thing, like the key ingredient is, let's say, NAD, or the key ingredient is spermidine, and the key ingredient is vitamin, whatever it may be, is the source of that ingredient is what's going to make a difference and determine the price.
The last thing I want to say is this. I love how you tied it together with resveratrol and SIRT1. Most of the skincare ingredients that people love and they think they're effective are going to get tied back to spermidine or to autophagy. Whether it is, you know, vitamin C as something that stops pigmentation, as we mentioned, whether it is things for barrier function. So there is another study that showed
spermidine, is really good for supporting skin barrier.
Yes, exactly. Specifically in humans, studies showing spermidine or autophagy is an integral part of a healthy skin barrier.
Which skin barrier is the foundation of health. You can't talk about anything, be the procedures you want to do if you don't have your skin barrier dialed in, or like really potent ingredients too. You have to have your skin barrier
exactly
dialed in.
collagen production we covered, you know. You can't if you have old collagen, you can't just put new collagen there. For that matter, how you create collagen, all of those things, they rely on autophagy, which relies on spermidine. Hyperpigmentation we mentioned. So mainly all of the things that you guys care, detoxification, all the things that you guys care about as far as how your skin looks, functions, etc., really goes back to autophagy and spermidine. And by the way, that's one of the hallmarks of aging.
Yeah.
So that's, I think, we can leave it at that.
Yeah, I think that's really, really good. Before we wrap up, we need to read the review.
Review. Yes. The reason we need to read the review is this. Look, guys, if you like this podcast,
we like it too.
We like it too. And more people should like it. No, more people should listen.
And the way we know if you like us, if you read a review, leave a review. If you don't leave a review, you actually don't like us.
Yeah, and you're not welcome here anymore. No, but we need to make sure people are educated, make sure people know what's good for their skin, how to turn their health around or to optimize their health. That's what we're about. And reviews help. So because they help us, we're going to help you. And anyone who we read their review, they're getting a free product. So if we're going to read your review now, either email us service@younggoose.com or DM us on Instagram, young_goose_skincare.
Yeah.
And let us know we read your review and we're going to send you a free product. So go ahead.
Yeah. Okay. So short and sweet. I love the way they explain the science behind skincare. I always listen on my way to work.
Very sweet and very short. Sweet.
Yes.
Who's the person?
Catalina Milado. So,
let's go.
Dear Catalina, I hope you're listening right now on your way to work. I hope you get there safe. I hope the workday is great, productive and fun at the same time. And to
Are you reviewing her review?
No, I'm just realizing that a lot of people probably right now listening on the way to work or commuting back home, and I just hope everyone makes it home safe. Okay, and yes, please reach out to us, either as I explained, DM or email, and we will send you. You know what? This one we'll send you a body cream.
Yes.
We'll keep it interesting.
We'll keep it interesting. Just for you to know, we're gonna have a companion booklet that you can download with actionable information about autophagy, skin related. That's going to be in the show notes. So look for it if you want to dive deeper, if you want to basically have actionable items after this podcast.
Yeah, this was more so a deep dive. So, when you hear autophagy, and you'll be hearing autophagy, from everywhere, you actually understand the mechanisms and the relevance.
So
we hope this was helpful.
We do. Bye.
Okay, bye.